Cool. All right. We're good to go. All right. So let's get cracking with this. Hello, everyone. Again, thanks for putting up with me a second time, if this is seeing me a second time. So rather than yesterday, this is where I actually talk about something technical instead. So today, I'm going to be discussing an update to what Kanidm has been up to. And yes, it really has been 3 years since I last spoke about this topic at a labs conference, so there's a lot to go over. The quick version, so who am I? For anyone on the recording or who hasn't met me, my name is William Brown. I am a senior software engineer here at SUSE Labs. I work on identity management technology, so I work on Kanidm, which I'll be talking about today, 389 Directory Server, which is one of the major open source LDAP servers, WebAuth and Rust. And for anyone who doesn't often get a chance to see me, it's because I live in Queensland, Australia. So I'm generally asleep when you're all awake. So if you've got any questions, send me an email, wbrown@suse.de, and I'm always happy to help out, chat or talk. So again, I have to apologise. I haven't given a talk about Kanidm since 2022. I couldn't attend labs last year because of a really important personal family event that I had to go to. So really sorry about that, and I'm here to rectify the situation. So in the last 3 years, this is everything we've done in Kanidm. This is the complete set of changelog and release notes. And yeah, great talk. Thanks for coming. Really appreciate it. Anyway, all right. So a little bit more seriously, since the last time we hit a big milestone. We released 1.0, and so apparently that's really important for everyone because as soon as you say, "Hey, this is a stable thing now," everyone starts going, "Oh, cool, we can use it," and then starts reporting even more bugs, which is excellent. Ever since 1.0, we've had fantastic people in our community, lots of users, and we've hit a number of really cool milestones from the last few years to now. We were the first open source IDM to support passkeys or WebAuthn. We were the first IDM, even amongst closed source ones, to my knowledge, to support passkey attestation, so cryptographic validation of what kind of authenticators you're using, which is a massive thing for security. And we're the first Unix PAM module to actually support TPMs for local account storage and security. And then now that technology is being used in other PAM and authentication providers like Himmelblau, which David will be talking about. I think tomorrow's your talk, David? Yeah, so also go see David's talk tomorrow. He's a cool guy. He's been doing some amazing work. So very worth seeing that. So yeah, we've hit a lot of big firsts and milestones. And of course, the most important thing that we've included. No, I'm joking. We haven't put any AI in it at all. So a few more dot points just for how Kani works. It's an identity management stack. We have a whole bunch of different features that a lot of other things don't. So we've now got our service account tokens can be used with LDAP, so you don't need to use like usernames, passwords with that. We've rewritten the entire web user interface, so it's like really fast, very light compared to what it was for. We've recently just added support for a whole bunch of stuff for load balancers like the X4 and proxy protocols. We can synchronize from other providers. We act as a single sign-on portal. We actually now have proper, eventually consistent replication, which I was actually still writing last time I was here in Pilsen. We've got QR codes for new device enrollment, account policy, and I could just keep going through, like there's a lot. But what's better than talking about something is a live demo. And of course, live demos, they don't go wrong, do they? So now I get to tempt fate. So the thing about Kani that I want to bring up first is that we have really good documentation. Like we've made that a really big key part of the project is everything is documented. All of this is all public, so we've got an entire book with different topics that even help with things like, hey, how to choose what domain name, how to do like server hardening, like everything about groups and users. So everything is here, documented, fully worked examples, makes it really easy to get started and get going. So in order to actually demonstrate that, let's do an install. So here I have a virtual machine, which I hope you can see. It may be a little bit dark. If it's a problem, I can make some changes. And of course, because I am a cool kid under the age of 40, I will be, in fact, using Docker. So first thing we do for doing a Kani install is we just create a storage volume. And like any good TV chef, I'm sitting here copy pasting because I prepared one earlier. When we want to create a new Kani server, all we have to do is specify what ports you want to use, give it the Docker volume that you want to use. Now that OpenSSL legacy conf, that's for something that I will touch on later. You do not normally need this. This is something specific for this demonstration. And I'm going to show you how we do this. So we've now created, we've already created our server instance now. And all we have to do from here is actually now configure that the server itself. So if I have a look here, I've got a server config I've prepared earlier. Again, like everything else in the project, extensively documented and commented. Things like, hey, what are your bind address? Where's your database path? What TLS key and chain do you want to use? Like domain names. We have online automatic backups. So, unlike a lot of other things where you've got to externally trigger the backups, we automatically just have a cron job basically internal to the server, which will automatically back up for you. So that just makes it super easy to have an instance where you actually know that your data is being backed up regularly, and then it makes it a lot easier for other tools to continue to back up. So I'm just going to copy these files in, and we're going to start the server up. And if we have a look, we can see that we are now ready to rock. Yes, Kani is full of silly jokes like this. And if I head over here to the kanidm.labs demo, there we go. That's it. That's how fast it is to set up an instance. It does help, of course, that I had pre-configured a couple of files, but really it is so quick to get started with setting up an instance of Kani. Now, you may have noticed that you didn't see me enter in any admin passwords or anything like that. And the reason for that is that we don't want to be having default passwords or anything like that, because that's just a security vulnerability waiting to happen. When you first configure your instance, we actually just expect you to recover that account via the local console, because if you have root on the machine, well, it's game over anyway. So the root user can recover our account. So I'm going to recover the IDM admin account. You see this nice machine-generated password here. Please don't steal that. It's very important that you don't. And I'm now going to log in. There we go. Very nice when things work, isn't it? So now that I've logged in, so we've got a complete suite of command line tools for administration of the server. So there's a whole bunch of different topics in here, obviously. Mostly it's command line administration at the moment. We are looking to expand our web administration aspects in the future. But for the moment, I think, what's the first thing we need to do in an identity management system? Well, we need someone in it. There's no point to an identity management system without storing people. So let's create a person. And, just like everything else I've mentioned so far, you can see that we have these really extensive help documents. Like the command line is really easy to explore and discover, so it makes it very easy to actually use and interact with day to day. You don't have these like really confusing commands like something like firewall D, where no one can understand or remember how the commands work. This makes it really easy. So we'll create a user. Let's be creative. We're going to call them test user. So that's going to be their name, and then we're going to give, this is their display name. And again, because I am under the age of 40, I think we should put some emoji in their name. What do you reckon? Taco? Taco? Yeah. All right. Apparently I say Tokio as the word taco, and it confused David for a few minutes the other day, which was, yeah. There we go. So we've now made our new user. And the first thing we can do with our new user here is we can set up their credentials. So we can say, okay, let's create a reset token. So this is not like, normally you'd be used to this idea of, oh, I'm going to reset their password and then I know the user's password and then give it to them. We don't do that. We create a reset token, which is very much in the vibe of like an email password reset. And, you can give this QR code to the person, you can send them this link here, or, you can run this command here as well. In this case, I am going to copy and follow the link. So now I'm updating my credentials for test user Taco. And you can see that when we're adding our credentials here, we try to prioritize passkeys, which is cryptographic hardware auth, and we try to deprioritize things like passwords. We obviously enforce MFA by default, so you would need to add TOTP here. So for me, I'm going to use my YubiKey, which obviously is very tiny and attached to my machine, and I'm going to enroll that here. And thanks to macOS for forcing you to jump through all of these hoops, to actually get to your key. That's because they want to try to lock you into their vendor lock-in environment. And they just really don't want to use the security key, so it makes it a bit painful. But anyway, so that's our YubiKey now enrolled, and you can see how quick that was just to set up and enroll a YubiKey. And that's great because now we have like full-on multi-factor cryptographic auth. So we'll save that. Log in as our test user. And my key is now blinking. The password's 1234, don't worry. And there we go, we've logged in. And now we can go and check our profile. We can update our credentials. Now, you would have noticed here we've immediately gone to re-authenticate. That's because in Kanidm, the way that sessions work is, I hope you would all know the pain of you getting logged in and out of services every couple of hours. Well, that's not how it works in Kanidm. The way that it works is sessions can be very long-lived. Within that session, you're actually only in a read-only state, and you have to basically do a sudo to temporarily elevate privileges to be able to change something, and then those privileges come back down. So you can have these very long-lived sessions. If the session ever gets stolen by someone, they still can't use it to do anything because they don't have your credentials to do that re-authentication. Something else that's really cool is this re-authentication. It has to be the exact same device that logged into the session in the first place. So you can't log in with a YubiKey and then someone steals your password and then use that. They're fundamentally incompatible. So in this case, I will re-authenticate. And again, now I can self-update my credentials. Now, if anyone here has used passkeys very much, you'll know that trying to get your YubiKey onto a phone is a right pain. Sometimes it has a different USB connector, things like that. So we have this really cool thing where you can enroll a device and the user can just go to their own profile, scan this QR code on another device, and if they do that, they then get that credential enrollment page now for their account on their phone. So this way, it makes it really easy to bootstrap in another device on an alternative ecosystem. It makes it really accessible and really approachable. So that's a really cool thing that we've done. We also, if you do end up choosing to do something like adding a password, like a really cool feature of what we've done with this is, again, like we really want to pay attention to human interaction. Like password rules are really silly. I'm not here to make everyone play the password game. That's not fun for anyone involved. But we want to encourage people to have good passwords. So if I enter this really short password here and I hit submit, you'll see we get this really nice actionable advice. Password is too short, needs to be at least 10 characters long. All right, let's repeat the same word twice then, because that's definitely secure. And now we get this other actionable advice. Add another word or two. Avoid repeated words and characters. Repeats like are only slightly harder to guess. Apparently there are repeats in the word password, probably because it's PASS, so that's why it's coming up with this. So now it's giving you this really nice, human-friendly, actionable advice on how to develop a good password and something like a passphrase. So this is way nicer than just having one of those obscure password policies with like, please use left caret, exclamation, things like that. So this is all well and good. We've now been able to log in, we've created some users, we can reset credentials. Maybe we want to be able to authenticate to another system. Like that's a really important thing, is being able to authenticate to other services. So unlike a lot of other identity services, you don't need an external OIDC provider such as Keycloak. This is all built in. So here's a Nextcloud instance that I prepared earlier, which I will be using in this demonstration. So what we're going to do is on the Kanidm side, OAuth 2 requires both parties to be aware of each other, the server and the client. Funnily enough, the Nextcloud is the client, not you, the user. OAuth terminology is silly. Let's not get too far into it. But each of them needs to be aware of each other. So first, we need to make Kanidm aware of Nextcloud's existence. So the first thing we're going to do is we are going to copy paste from my previous notes. So we're going to create a new Nextcloud provider or client. We're going to call it Nextcloud, and then this is the URL to that application. So we're going to create that. And then now, of course, we want to be able to control who can or cannot access this application. That's a really important part of giving out, for an identity service. So let's make a group that controls who is allowed to log into this service. And for obvious reasons, because I have been using our test user, I'm going to add a member to our Nextcloud access group of our test user. So now they have that membership, so they will be allowed to log into Nextcloud. And if you were not a part of this group, you can't. So now we've got the group, but now we need to make Nextcloud aware of how that works. OAuth 2 does not have a concept of groups at all. What it has is a concept of scopes. And scopes are just labels that it says, do you have this label permission or not? So the way that we handle this in Kani is we have the ability to map that the scopes requested, you have to be a member of a group to have access to that scope. So this allows you to use groups to give roles and then project those into something like Nextcloud. So if we look here in our Nextcloud configuration, we can see that the scope's being requested. It's a bit small. It's OpenID, email, and groups. So we need to make sure that these are available so that if all three of these need to be satisfied for the user login. So we'll create a scope map. And what this scope map does for the Nextcloud application is it says, for members of the group Nextcloud access, you have access to the scopes OpenID, groups, and email. So we're saying, if you are in this group, you get those scopes, you can proceed. You could imagine you could also have, say, a Nextcloud admins group, which has the scope admin. And so you can then use Kani to actually control roles inside of external applications. So we'll create that. And the final piece of the puzzle is that Nextcloud needs to be able to authenticate to Kani so that we know that it's that application coming in. So for this, OAuth normally uses a basic secret. Again, we'll generate that on the Kani server, and we now need to go and give this to Nextcloud. Please don't copy my secrets again. All right. So now that we've done that, we can come over here, and Nextcloud is aware, obviously, of Kani. I pre-configured that. There's an OpenID discovery, and now we can select login with Kani. Oh, okay. No, I got you. That error is intentional. See, this is the problem, is that I don't react negatively enough when the error panicked enough, and no one believes it. Everyone just goes, nah, he's joking, he's messing with us. So I've actually intentionally put an error in here in order to help show a really nice capability of what Kani can do. So we can see that we have this operation ID here. It might be a little bit small, but this operation ID is a UUID. This UUID is unique to every single is generated for each request made to the server. So if you've got multiple servers and you have a log aggregator, you just get given this UUID. You can go and find exactly what happened in the logs. So I'm going to come back over here to our Docker instance, and I can look through the logs for that UUID, and I immediately find the relevant log lines for what just happened and what the failure was. And we can immediately see here, the line is, we have an invalid OAuth 2 redirection URL. So when Nextcloud went to Kani, it said, please send me back to this location. And Kani said, nah, I don't trust where you want me to go. You could be trying to steal the user's token. I don't trust that URL. Go away. You need to give it that setup. Now, some other little stuff you might notice here with these logs, it doesn't really format very well here on the large screen, but this is actually a tree-based structure. And so each section of the tree, so the outer scope here is representing 100% of the operation time, which took 555 microseconds. And then within that period, we can see that 60% of the operation was inside of this handle OAuth 2 authorized at 334 microseconds, and then 223 was validate auth. So we have profiling information here in this nested layout. So you can see, okay, my operation took this long. How long did each part take? And you can immediately find at a high level where potential performance problems are, and then actually potentially address them. So it also helps to understand with what area of the code was being hit at a point in time. So we have this really nice built-in observability from the start. And of course, that's on by default because it's always better to be able to visually see and find something as an admin than to have to, turn on the debug and then reset everything and try and recreate the problem. We need this evidence. So this logging library is really cool. Anyway, so now we need to update our redirect URL in order to make Nextcloud happy. That way we have that way we can actually log in. And so again, I'm going to, here's one I prepared earlier because I'm a good TV chef. User OIDC/code. Cool. So now Nextcloud, so I've told Kani now, hey, actually, when Nextcloud comes to you and says redirect me over here, yes, this is a valid place for you to send the user back to. So now what we're going to do is we are going to come back over here, log into Nextcloud, going to click login with Kani, and immediately we've got a very different page. It's worked. So because we'd already logged in as our test user, we're still in the test user context, and we're being asked to consent to proceed to Nextcloud. And something that's really important here is that because one of the scopes requested was email, that's personally identifiable information. We actually tell the user, hey, Nextcloud wants to see your email, is this okay? And you have to consent to proceed. If those scopes on your account ever change, you have to go through this again. That way, you always know as the user what information is or is not being shared with a third party. So here we can proceed. Now, at this point, I click proceed. You might see a little bit of slowness. This is all Nextcloud being slow, not Kani. Kani was done a few seconds ago. And as you can see, we've now logged in as our test user to Nextcloud. And even the emoji comes through, which is really cool. So this makes it really easy to, again, integrate web applications and other applications. And something that you will now see when I come back here is that if I was to log in on the front page, there's a list of the applications that are linked to the Kanidm instance. And because I, as the test user, have access to Nextcloud, this appears in my portal. And of course, I can click this link and it takes me straight to that application. So you have that very similar to Okta. You've got that application portal and it only shows you what you have access to, which makes it really nice for you as the user. You just go, oh, I'm just going to go to the central portal and then just jump onto everything else. Yes, you can theme this, by the way. You can actually change all the OAuth logos and the server logos and stuff like that. I just didn't have time to prepare those for this demonstration. All right, so we have an identity management system. We can create users. We can log into web applications. And now I think the one that most people in this room would actually care about is, can I log into a Unix system? Can I SSH to something? And the answer is yes. So what we're going to do now is we're going to set up our user to be able to SSH into something. So the first thing we're going to do is we're going to enable POSIX attributes on our test user. So, sorry, let me just show the test user here. Oops. So now on our test user, you can see that we've now got a generated GID number. Now, this is what's really important is that for all intents and purposes, on a Linux system, your GID number and your UID number are basically effectively the same thing because primary group has a lot of influences on primary user. And so we just give you a GID number because you need a user private group. And so this GID number implies what your UID is. So we only have one ID number. We also adhere within all of the we have to work within all the limits that Systemd has put on us they've reserved a bunch of UIDs. So we have to be very careful about this. And this is randomized and all of that nice stuff. So what we can do now is, so our user here has got POSIX attributes. They're all set up, ready to go. But the user still needs an SSH key to be able to log into a system. So what I'm going to do is I'm going to come over here. Now, this terminal isn't remoted into a VM. This is actually on my native machine, hardware-wise. And what I can do is I can actually log in as our test user. Now, you'll remember before that I enrolled with my YubiKey. This is me using my YubiKey on the command line. The same one that I enrolled through the browser is accessible via command line tools. And in the future, we want to make it accessible so that you can use this for logging in with something like PAM and stuff like that. So I've now logged in with just my YubiKey on the command line, which is really cool again. You don't need to muck around with passwords or anything like that. And now, as my user, I can set up my POSIX account password. And the reason for this is that obviously this account doesn't have a password. It's only got the YubiKey. But unfortunately, PAM on Linux is very primitive, and especially over SSH, you can't really forward a YubiKey in a secure manner. So you're pretty much resigned to having a sudo password. And so as a result, we keep that password separate from everything else that you do on the system. It's just for sudo, and we try to really keep that away from things to prevent that credential being compromised, especially since it is just a single factor. So we've now set a password for our user. So they can do that themselves. As again, I've logged in as the test user, so they are actually doing that themselves. And I'm a big fan of security keys. If you haven't heard me say the word like 14 times already in this talk. So I'm going to create a SSH key on my security key for our test user. So there we go. I've now created an SSH key again on my YubiKey for my test user. And that's really good because, again, it means that the private key never leaves my devices. It can't be remotely exfiltrated or stolen, which is fantastic for our account security. And I can now enroll my newly created key into my account. And if I show that person again, you can now see that the uploaded key now exists. Now, this is really important, is that we do actually support those YubiKeys in these locations, because there's a number of providers that don't. And it's very obvious when they don't, because you try and enroll a key and you get a weird error like, nah, that's an unsupported format. And you're like, well, do I have to really store my key on disk again? Anyway, no, we support all of the hardware-backed cryptography, all of that nice stuff. So in order we need a client machine. So here's a third machine that I've set up earlier. So we've now got our user configured with SSH and stuff all ready to go. Now we need to configure the client machine to trust Kani as its auth provider. So the way that this is done is similar to TripleSD. There's a local resolver on the machine that you can install. And again, like as before, extensively commented file, you can do stuff like it can support like a TPM, so that credentials stored on the machine are cryptographically stored within the TPM so that they cannot be exfiltrated by an attacker, because the local cache of passwords is obviously a high-value target. So again, like there's a whole bunch of different options in here for like dealing with default shells, home prefixes, things like that. So I have already started that up. I've already set this up earlier. Something that you'll find really cool potentially is that you'll notice that this goes against normal advice, is that the Kani module is ahead of Compat. That's because Kanidm now has the capability of replacing PAM Unix. And so this is actually able to resolve from Etsy password, Etsy shadow, all of that, and it's significantly faster. And so we're starting to like integrate that, and then potentially TPM stuff in the future as well. Similar with PAM. This will probably be an interesting one. No PAM Unix in here, yet I can still log in. So this is down here, sorry, but you'll see no PAM Unix whatsoever, but I can still log in as root if I wanted with my password. So, and then the goal is, again, to be able to integrate stuff with TPMs in the future. So this machine is set up and configured to authenticate to our Kani instance. Again, I'm trying to go over this pretty quickly. Now, you'll notice that I've just hit systemctl enable now on the resolver daemon, which is a separate process so that it's hardened and isolated so that it can't have credentials stolen. You would have noticed it took a second for it to start up. That's because on startup, we actually benchmark your CPU to work out how many rounds of Argon 2ID can we perform to make sure that we're basically doing as much as possible within a time window. We're not just going to say, let's do X amount of rounds of this KDF. We're going to do as much as possible to hit a time threshold. And again, this is really important for these client machines where the cache database could potentially be exfiltrated. So we want that defense in depth with multiple different layers here. Even though this is in the TPM and goes through a TPM as well, we still need this extra defense. So at this point, our client machine is configured, and in order to just, again, we're going to make sure that only certain users from certain groups can log in. So we're going to create a Unix allowed login group. We need to set this Unix allowed login group up with POSIX attributes. So we've now, again, generated the GID number. You can manually set these if you want, but we have a way of automatically generating these. And we're going to add our test user here to our group, and they will now be able to log in. So what I can do now is from my host machine, I can SSH, I can touch my key, and I've now logged into my machine like that. So you would have seen I only enrolled the SSH key into Kanidm. I didn't have to like copy it anywhere, and it's stored on the YubiKey. So I've basically gone, it does SSH key distribution, the whole works. It makes it very easy to actually centrally control SSH keys, to then remove them, revoke them from a central location, and then they get distributed out to client machines, and they can be used in a whole bunch of different ways. So you can see that I'm the test user, I'm part of the Unix Allowed login group. You can see that my home directory is the test user one, and I can touch a hello labs file, and we can see that it's there. Now, this is the one that this is the part of the demo that always gets a reaction. So the thing about an identity management system is that people have to be able to change their name, right? That is a fundamental rule of humanity. People change their names. They get married, they want to re-identify, something happens, they have a bad experience, I don't know. People change names. It happens. But so often we have identity systems that cannot allow name changes. Kanidm does. So as the user, you can, by default, users can change their own name at any time. And for anyone who is a long-term Linux sysadmin, this will send a shiver down your spine. But I'm going to, yes, I know. I've had like 3 people tell me it's 10 minutes now. So, okay, Noel's doing his job, mate. He's doing a great job down here, Anyway, so now I'm going to update this person's name, and they can do it by themselves. So I'm going to rename them to Meow because I'm a cat dad, so that was the first word that came to mind when I did this. So now my account is named Meow. I'm going to log back in to that machine that I was just on with my new username, touch my key, and I've logged in with the same ID number in the same home directory, and it's even updated the home directory path. All when the user renamed themselves, everything just worked. So, and most people, if you were to say that, they would be like, how? We went to a lot of effort to make this work. I'm going to say that now. So there's a lot of cool stuff. I've really had to try to blow through this really quickly. But some of you might be saying, hey, this seems really cool. I want to start using this or give it a go, but I already have something that I'm using. So I prepared a free IPA instance here. This free IPA instance, my test user is Fraser. He's a mate of mine from Brisbane, works on free IPA, lovely guy. And, so he's my demo account here on the free IPA instance. But in this instance, I also just decided, just for the fun of it, I'm going to add 10,000 users and 5,000 groups as well, just to really make the migration a bit of a challenge here. And I'm going to migrate the whole thing live. So we can see here on Fraser's account, he's got a SSH key, he's got 2-factor enabled with TOTP. Sorry, this is a bit small on the screen, so you'll have to believe me on this one. So what we can do is, on the Kanidm side, is we can actually create a synchronization agreement. So I'm going to tell Kanidm, hey, you can now, oops, sorry, I need to log in as a different user, don't I? There we go. There we go. Here's a really cool quirk, actually. I'll clear the screen so it's at the top. You can see now that when I go to do something, because I've got 2 active sessions, it asks you which session do you want to use. So if you've got multiple sessions on the command line, you can actually flick between them as well, which is a really nice little detail. So now I've actually created my IPA synchronization. So this tells Kanidm, hey, you're now ready to receive users from another source. I'm going to tell Kanidm that, hey, when someone who is being brought in tries to change their password, obviously they can't because it's being synchronized from an external authority. We don't own that data. We're just mirroring it at this time. They need to go over to this portal instead. And the last thing I need to do is set up a synchronization token. So this is just an API token which allows the synchronization tool that sits in the middle to actually authenticate to Kanidm on either side. So again, please don't steal this. Very important. Where is this file? There. So now I'm going to, as I mentioned, I'm just going to update my sync configuration with that token. And again, as before, everything here is very well commented. There's a cron-like schedule of how frequently to synchronize between the two, what we sync, and there's even a number of things like being able to remap and modify problematic entries on the fly if anything comes up during the data migration. So now that we've run that, I'm going to run the sync tool. We have to, again, it runs in Docker. It looks like a scary command line. It's not that bad. Run it as an isolated user. There's a status monitoring port so that you can check your sync status with a monitoring tool. We just bind in hosts. We need the Kanidm config, the CA certificates for both Kanidm and IPA so that we have a root of trust in each. And we have the actual sync config, which is going to give that API token. And we're going to run the synchronization now. So to start with, we run the sync and we do a dry run. And it says, yep, success. So let's go ahead and do this without the dry run. So we're going to run that one there, and we've now started synchronizing our users into Kanidm. Now, this is where the openssl.conf was needed because FreeIPA's passwords are stored in MD4. So we need to be able to import that, and that requires the OpenSSL legacy module. We've now got a way to work around that. So there we go. We've now imported all our users in 14 seconds. So that was 15,000 entries brought over in 14 seconds. I think that's pretty nice. And if we go over to our Kanidm instance, and hang on, let me just log out here. I can actually now log in as, I can now log in as Fraser here. So I hit Fraser, but you'll also notice it's autofilled his TOTP and his password in the background. We've got some really cool web stuff to do that. And there we go. Fraser's been migrated. We've got his TOTP, his password, his SSH key is here, so he can now SSH into that other client machine if he's in the Unix groups. You can see he can't see Nextcloud. If we added him, he would be able to see that. And then later on, we can finish that migration and he would be able to update stuff. At this point, you can also add capabilities. So you can say, hey, FreeIPA doesn't support passkeys, at least not in the same way that we do. FreeIPA, and you can tell it, actually, let's remove FreeIPA's authority over passkeys, give it to Kanidm, and then you can put passkeys into Kanidm so you get that really nice security key integration that we have that FreeIPA doesn't have quite as polished. So that's the demo. And that was probably a bit of a roller coaster. Now, there's a whole bunch of stuff that we want to achieve in the future. We want to do a lot more integration of stuff like on the client side, like proper domain joining, so the client machines aren't just like anonymous. We want them to actually have an identity, a lot more integration with the TPM for cryptographic material and distribution of stuff. We do secretly actually have smart card support working. It's not a publicly advertised feature, and you have to do a little bit of effort to make it work. I'm currently trialing it at home all the time. But we want to complete that. So you should have like a CA, and then you can enroll smart cards, and then they can automatically become SSH keys with a PKCS11 module or whatever. We've already started re-architecting our internals, and we're almost there to be able to store every private cryptographic key in a hardware security module on the server side, which is a really important one to prevent attacks and exfiltration of private key material, especially in hosted environments. We have a SCIM API that we need to finish up. We're currently working on that at the moment, so that should be done in a couple of months. We're adding a Kerberos distribution center for Samba file shares, both for local user authentication with the NTLM deprecation coming out of Microsoft, but also for Kanidm itself. Lots of improvements for monitoring. That's an area we need. And I would be remiss if I didn't acknowledge the weaknesses of Kanidm, and monitoring at the moment is a weakness. We do need to improve that, like being able to give better reports about the health of the system and when errors do occur. Part of the problem is that errors occur so infrequently that people haven't pushed for us to add more monitoring, so we haven't had the need. Better auditing of events, so like an audit log of, hey, this person changed his password at this time. That's somewhere that we need to improve. And our web UI is very sparse and not very pretty. I'm not a web developer, unfortunately, but we do have some really good community members starting to step up. So if you are someone who is good at web stuff, please help me. I really need the help. Future for the PAM side. This is probably something where we actually need to start breaking this out, because we've had a lot of collaboration with our PAM tools with David Mulder and Himmelblau, because we're sharing a lot of that code, and we need to start to do a lot more there to better collaborate. Localhost KDC for when Microsoft gets rid of NTLM. That way, user-to-user authentication can still work. We want to add some extra auth providers, things like an LDAP-S backend, to allow users of TripleSD to migrate over. Things like CTAP2, which is what YubiKeys actually speak with. That way you can do local auth with a security key rather than a password. We do want to do distribution of CTAP2 keys from Kanidm as a server to remote clients. But the problem is that, again, PAM is just a bit primitive and poorly documented, and it's really hard to know if an auth session is coming from a local or remote user. So if someone SSHs in versus logs in with GDM and they type sudo doesn't know whether the session is local or remote. All it knows is someone has typed sudo. So we don't know, can we actually offer them the YubiKey or not? Because if they're SSH, they don't have a physical key. They can't touch it. So that's a problem. So this is actually the real finale. Thank you for coming along and spending your time to watch this. I hope it was at least interesting, informative. This is what we've been up to for the last few years. I think I am at time, so I will not have time for questions, but I will have time for questions later in the day. I have a meeting at lunchtime, so actually it's coffee now. So please come and get me at coffee, and I'm happy to answer any questions you may have. So thank you very much.